How's it going, pre-calc people? So, this is our last lesson for the year. All right, yeah, we're down to the end. But yeah, this is going to be the completion. We're going to finish the year with lesson 7.1, nonlinear systems. Last week we did linear systems, which meant two equations, both of them were straight lines. You know, straight lines, they either cross each other, one solution, they are parallel to each other, no solution, or they're right on top of each other, meaning the same line, and therefore infinite solutions. Those were your options. Well, now we're doing linear is still a part of it, but we're involving things that aren't linear. We're involving parabolas, we're involving cubic functions, we're involving circles. And so they can intersect in a different way. So I have 4 examples total. 2 are up on the board now, and I'll work those out, pause, erase, get ready, and all that, you know the routine. So this first example, just kind of set the mind on how this could happen. This first thing, 2x minus y equals -8, that's straight line. How come? It's just x and y, no fancy crap, no x squares, no y squares, no square roots, no straight line. Y equals x squared, the x squared only, that's a parabola. So you need to understand a parabola and a line can combine in one of 3 ways. A line and a parabola can intersect twice. I'm just going to draw a quick diagram. If you have a parabola that looks like this in any way, shape, or form, the line can cut across like that, hits the parabola 2 times, there's 2 solutions, 2 ordered pairs, that is, 2 x's and 2 y's. You can have a situation where you have a parabola and the line touches 1 time like that. So you can get 1 solution. And then lastly, the line misses totally. No solution. So you have to understand your options with a line and a parabola are 2 solutions, 1 solution, no solution. There's no infinite. They don't overlap. They're not the same shape, so they don't sit there and just overlap in infinitely many places. Okay? Now, these systems will be solved the same way that I showed you linear systems. They will be solved with elimination and substitution, and sometimes based on how the equation looks. Because one of these equations says y equals, I'm going to use substitution on this one. So it says that y equals x squared. I'm going to put that right there. So I'm going to rewrite this equation with the substitution in place. It'll look like this. 2x, the minus is built in, x squared goes there, like so. Now you guys were going to solve this for x. I would have done any simplification that I could, but there's no like combining like terms or anything. That's an x squared, that's a number, they're all different. However, the fact that this is an x and this is an x squared means I'm going to use factoring to solve. And if factoring doesn't work, I use the quadratic formula. When I'm doing factoring, the x squared thing, that's kind of supposed to be our lead. I want it positive, which means because it's minus right now, I'm moving everything to this side of the equation. So I will add x squared to each side and subtract 2x from each side. Now, these are all stacked, messy looking, but they're not like terms, so I'm going to put them in the order that I want, which is x squared first, x second, number third. So that'll be x squared minus 2x minus 8. Okay, let's move that over here. Make it look a little nicer. X squared minus 2x minus 8, set it equal to 0. Doesn't matter if I have equal to 0 there or equal to 0 here. It looks nicer this way. Going to attempt to factor this. With this being -8 and that being -2x, this is going to be -4 and +2. Check it out. If you distribute this all back together again, get exactly that. Okay? At this point, because it's this times this equaling 0, set both of these equal to 0. So x minus 4 equals 0 solves out as x equals 4, because you would add 4 to both sides. X plus 2 equaling 0, you would subtract 2 from both sides and get x equals negative 2. Now notice I didn't circle those yet because those are the x's, meaning this was the situation of a parabola with the line intersecting it in two places, because I got two x's. Well, I need the two y's that partner with them. So I need to substitute these back in to get y. That equation is the easiest for us to do that. You're going to get two separate ordered pairs. This x will be 4, this x will be negative 2, and we'll plug that in. And then this is not a bad equation. You plug your x in and square it. So if I plug a 4 in right there, 4 squared is 16. And then if I go over here and plug the negative 2 in, negative 2 squared is positive 4. And there is your solution. Now, just a word of advice. Some of these are easier to do this than others. But you have the option to graph this a minute and see if it resembles these two solutions. Now this equation's not in, like, you know, when you graph, you do y equals. You'd have to quickly convert that. This one would actually be y equals 2x plus 8. So if I did 2x plus 8 in one equation and did x squared in the other equation and hit graph, it'll draw the line and the parabola. Now, negative 2, 4 is the one you see intersecting over here. You can imagine, I think, because 4, 16 is going to be up here somewhere. So you can imagine that it's going to be okay. Now, you don't have to check these. In fact, some of them are kind of challenging to check. So yeah. So there's that one. We have a parabola and a line intersecting in two spots. There we go. Okay, over here. Now, the thing with this one is they look weird, but I want you to understand the top equation, even though it's got the x's and the y's all on the same side, this is a parabola still. It's got an x squared, it has a y in it, makes it a parabola. This is just x and y, no squares, no fancy stuff, that's a line. So we're in the same situation here, a line and a parabola. So we know that our options are going to be intersect twice, intersect once, intersect no times. Infinite, not an option. However, because the way this one is set up, all the variables are over here, equal sign and ones and negative ones and numbers, doesn't matter what they are really. I'm going to use elimination. And please understand, the only variable you have the option of eliminating is y. Because y is the only variable that's y and y. See, you don't even have the option to say, well, I could get these two x's to read, I could get them to cancel somehow, I could work it. You couldn't get this to cancel. See, the fact that there's x squared and x, the x is off limits for the elimination. But these y's couldn't be like in a more perfect position. So right this second, folks, adding these two equations together. So the x squared is just x squared plus nothing, so x squared. Be careful here, that's considered negative 1x plus negative 1x for negative 2x. That's negative y plus y, they cancel. And that's 1 plus negative 1 or 0. We're going to solve that equation. Because there's x squared and x in the question together, we are going to factor. The factoring is greatest common factor to start. Pull an x, that leaves me x minus 2. And that's not only the factoring to start, that's all there is available. This doesn't factor any further. So you are supposed to set this and this equal to 0. Set x equal to 0. Set x minus 2 equal to 0. Solve that by adding 2 and get x equals 2. So those are your two x's. So we're going to be in that same boat again. I'll get it ready over here. We're going to have 2 points. In other words, this is another situation where the parabola and the line cross each other twice. This equation is easier to substitute and solve because this has got more stuff in it. And I'm actually going to write this out a little bit better. So I have to put a 0 in for this x. Now I'm going to just kind of like do this by the book. So there's an understood minus sign sitting right there. I put a 0 in for x plus y equals -1. Now let's be clear. There's no such thing as -0 or +0. It's 0. In other words, this doesn't even matter because it's 0, and I get y equals -1. In other words, when x equals 0, y equals -1. This time using the 2, using the same equation, I'm going to put down negative for the existing negative. My x is 2 plus y equals -1. This time I will add 2 to both sides. And I get y equals -1 plus 2 or 1. And you guys, just for your own information, if I want to make both of these equations say y equals, which is not super difficult to do, I could plot them on a graph just a quick minute and make sure they really intersect at 0, -1, and 2, 1 to make sure that that I didn't make a stupid mistake. I mean, it's always possible. So, yeah. So there's the start. I'm going to erase, put a couple more examples up there, and we're going to just look at what's left. All right, guys, I got my next 2 examples up here. Now, I mean, kind of saved the best for last, of course. These are a little bit different. So this problem right here is a cubic function with a line. And a cubic function, you know, can kind of has that shape of it can go down and it can loop up, like, you know, can do things like this. And so the possibilities are it could cross 3 places, you know, because if you get a cubic function that looks like this, and the line just happens to hit like that, right in the right spot, it hits 3 places. It could also hit in 1 place. I'm trying to, and I can imagine it could hit in 2 places. You know, if it crossed up here and hit 1 place, or crossed down here and only hit 1 place, but if it nicked the top of that and then hit, you know, so we're looking at, however, unless it's a vertical line, which it is not, it can't miss the graph. So we're looking at 1 solution, 2 solutions, or 3 solutions, not no solutions. That sounds weird to say, not no. Can't have no solutions, and you can't have infinite because they don't overlap in a bunch of places. It's a straight line and a bunch of curves. So anyway, here we go. We have a couple of options here. I understand they both say y equals, which means substitution is a go-to. But please understand that elimination is allowed because these do line up perfectly in terms of the y's are here, the equals, and all the x's are here. You could force the y's to cancel and go that route too. I'm going to do substitution. I'm going to say y equals this, so this goes there. Okay? So that's x cubed minus 5x equals x. Okay? That's what I'm dealing with. Basically, one equation in for the other. That's kind of how it works. This is, you know, x cubed and x being mixed together is just like x squared and x being mixed together. You're going to get everything to one side and attempt to factor this. So I'm going to move this x to that side, which means I am subtracting x, which gets me x cubed minus 6x equals 0. Okay? The factoring that is going to take place is that I can take a common factor of x. So GCF of x leaves me x squared minus 6 equals 0. Okay, since I'm going to go over here with this work, now I need to take this and this and set it equal to 0 and solve. Okay? So with that being said, setting x equal to 0 is not a big deal. Setting x squared minus 6 equal to 0. Gonna be kind of a pain in the butt, but we'll make it work. Okay? We're gonna take here, we're going to add 6 to both sides. We get x squared equals 6. We're going to square root both sides, and we get x equals plus or minus. Now this isn't nice, and I normally don't like to go to decimals very much here, but we're going to go to decimals because it's pain in the butt. So we're going to do the square root of 6 into 3 decimal places. That helps us be a little accurate. It's going to be 2.449. Now, we actually have 3 x's, which means we're going to have 3 ordered pairs. And one x is going to be 0, one's going to be 2.449, and the other is going to be negative 2.449. Now, the nice part about this, I can choose either equation to plug these back into. That's about as easy as it gets. Y is equal to whatever x is. That's kind of nice. So if x is 0, y is 0. If x is 2.449, so is y. And so is y negative 2.449. Now, just to kind of, because I don't, this isn't the nicest set of answers. Let's kind of check this out a little bit. We'll go to graph this. They're already y equals, so that's kind of nice. This is x to the third minus 5x. That's in line 1. And then the other one, we're just going to do y equals x. Now, we're going to hit graph. And we get this picture. So you can see that the 0, 0 definitely happened, and you can see those other 2 points. If you can look at them close enough, you can see that they're 2.449, so roughly about 2.5, 2.5, and negative 2.5, negative 2.5. Granted, those answers aren't the most pleasant thing in the world. It worked out. So that is the thing you have to deal with as a pre-calc student. Not everything's all perfectly nice answers. It worked out like this, and it wasn't the worst thing. This y equals x really helped us out, being like, hey, whatever x is, y is. Okay. All right, last one's kind of a doozy, so be ready. We haven't discussed this as much as we normally would in class, so I'm going to kind of cut to the chase, the easy version. This has got x squared and y squared. X squared plus y squared equals 9. Folks, that's a circle. Okay? Specifically, it's a circle of radius 3, actually. And then this, because it's just x and y, is a line. So please understand, a circle and a line can intersect twice. The line can cut the circle twice. The line can just hit the edge of the circle once, and the line can miss the circle totally. So we can get no solutions, 1 solution, or 2 solutions. Now, this one's just like not ready to do anything. Like, 1, I can't do elimination. I could not eliminate my x's. One's an x squared, one's an x. You can't eliminate them. They're not even like terms. And the y squares are the same. It's not even set up for us to do substitution, but we're going to make it that way. The fact that this is just sitting here as kind of a single y, like 3x is a pain. I don't want to solve for x because it would require me to divide by 3. But this is okay. Now, here's the move I'm going to make. I'm going to move the y over to this side so that it's positive, and I'm going to move the 2 over to that side so it says y equals. So I'm going to do that all at once. I'm going to add y and subtract 2. Kind of looking messy here, but That's out and that's out. This has the y over here, and this is 3x minus 2. Okay, again, a fair warning. This takes a little bit of fumbling around to get it done. Okay, so y equals this. It's gonna go there. Please understand, you can't substitute it into this. This is that one. It's just a reorganized version, so you got to plug it into the other one. So that becomes x squared plus, in place of that y, you're putting 3x minus 2. So it needs to look like that. Equals 9. So x squared, maybe in the margin off to the side somewhere, you got to square this out properly. Meaning, I'll go right over in this little corner. I got to do 3x minus 2 times 3x minus 2. That's what squaring that means. That becomes 9x squared minus 6x minus 6x plus 4. Which when combined gives me 9x squared minus 12x plus 4 equals 9. Okay, so that's some of the tedious, kind of messy stuff. We have to organize this and get ready to solve it. First of all, combine like terms. X squared and 9x squared is 10x squared. Minus 12x plus 4 equals 9. The fact that this has x squared and x in it's another factoring question. That means I need it to say equals 0, which means I'm moving the 9 over. So I am going to subtract 9 from both sides, which gets me 10x squared minus 12x minus 5 equal to 0. Okay, we got our work cut out for us, people. I'm going to get rid of that because that's, you can always pause the video and go back to that if you needed to see that for a second. Let's move this up here. 10x squared minus 12x minus 5 equal to 0. Okay. We have our options of being able to factor that or go to the quadratic formula. Now I'm going to check a little something because I want to see, I'm not going to waste my time trying to factor it if it doesn't factor. So I'm going to kind of look at something here a minute to see if it factors nicely or not. Doesn't look super nice to me. So we are going to go right to the quadratic formula, which I know is not probably your favorite thing in the world. Oh well. In terms of the quadratic formula, this is A, this is B, this is C. And we'll go into the quadratic formula, which is x equals the opposite of b. So 12 plus or minus the square root of b squared. That squared is 144 minus 4ac, which is 10 and negative 5, all over 2 times a being 10. 12 plus or minus the square root of over 20. So checking this out a second, let's see, 144 minus 4 times 10 times negative 5 was 344. And I can tell because 344 is not a perfect square. These are not going to be pleasant answers, but like I said, we're at that level where things aren't always pleasant, especially when you're messing with circles and lines and parabolas and cubic functions and all that good stuff. So right now what I'm doing right here in front of you is 12 plus the square root of 344, enter, divide by 20. That's 1.527. That's one of my x's. And then the other one is 12 minus the square root of 344. Divide by 20. And that's negative 0.327. So there are the x's. Okay? Which means we're going to have 2 points. We're going to have the circle and the line intersecting in 2 places. So we'll have 1 point. That's 1.527 comma. And the other one's going to be negative 0.327 comma. For purposes of being as easy as possible and moving along here, because I want to keep this under 30 minutes, otherwise it cuts me off. We're going to take these 2 x's and we're going to plug them back into this equation. It's this version of this equation, so this is the easy way to do it. Y equals, we're going to do 3 times the x minus 2. So 3 times 1.527 minus 2. That's 2.581. And then same for this one. 3 times negative 0.327 minus 2. So 3 times negative 0.327 minus 2. We're looking at negative 2.981. All right, so that's that, people. So I told you I saved the best for last. Of course, and you know what I meant by that sarcasm. So yeah, things don't always work out just all pleasant, especially when you're dealing with these kind of systems. So that's kind of the closing deal. You'll have one final assignment. It's actually out of the textbook, so I've taken a picture of the textbook and turned it into a PDF, and that's what you'll see. You'll only be doing certain problems off of that page, of course, and I'll tell you which ones to do. So you shouldn't see anything out of the ordinary from what I've told you. You should be able to manage based on the examples that I've shown you. The things that I show you should be relatively similar in terms of how you solve them, either by substitution or elimination, whatever your choice is. All right, take care, guys.